The story we've been telling over the last 3 years through these podcasts and these videos is of a new industrial revolution. Where steel communities were originally founded around iron ore and coal, the opportunity going forward is to found those steel industries around renewable energy and the access to native scrap in the UK. Now, we all know now that the company here is investing £1.25 billion in a program of low CO2 steel making, and lots of people will know that that involves the introduction of electric arc furnace steel making technology here. But of course, on top of that, there's other things we're doing. So there's a life extension project for the casters, there's an investment in the crop shear and coil box in a hot mill, and there's a brand new pickle line as well as part of that investment. This is one of Tata Group's mega projects across the world. There's Agratas, the battery factory across in Somerset, and the investment in low CO2 steelmaking here in Port Talbot. So I've been waiting 3 years really to make this podcast because we've been anticipating that project starting. Now we've had the contract signed with Conveyor, got planning permission from Neath Port Talbot Borough Council. There's a few more things to sign off before we can get spades in the ground on the project in the summer, hopefully in July. And so today we're going to be telling you the story, or the first part of the story, about that investment in electric arc furnace steel making. And who better to show us around what that's going to look like is the program manager, Peter Jones. Peter, listen, I've been really looking forward to this. Thanks so much for joining us and spending some time with us today. And I think we're going to walk around kind of start to finish pretty much of steel being made on the site going forwards. But, you know, people may not have met you before, won't know much about you, Peter. You're another lifer in the industry. Tell us a bit about how you got to this place today.
Well, going right back to the start, I went on a trip as an undergraduate to the hot strip mill here many years ago, in 1990 I think it was, and I was hooked, strangely enough.
Yeah.
It didn't take much really then to move on, and I joined the company in 1991. I actually started in the tin plate works in Ebervale.
Yeah.
I think you were there for a little while.
Yeah, that's right.
And really moved through the company through engineering jobs, operations jobs, and I've moved around. You know, Ebervale has since disappeared, but Trostra, I've worked at Trostra, and I've worked pretty much over most of Port Talbot Steelworks as well.
Yeah, and of course you're a works manager in the steel plant where we'll be heading to a bit later on, so you know that place as well as anybody. Now today we're going to go through that start to finish process as I described. Now we're starting here at what is called the knuckle yard.
Yes.
Tell us a bit about what we're seeing here in front of us.
This is where all of our mainline trains come in. So in the future, all of our scrap will be coming in through here from all of the locations throughout the UK where scrap will be being delivered from. So that will be coming into this yard and be roughly at full production, 70,000 tonnes per week coming into this yard.
Wow. To
be converted then into finished product at the electric arc furnace. There will also be materials coming in from Newport docks, and all of that will have to come through this yard. Obviously this yard, and you can probably see some of the wagons across the way here, we also are, this is our outlet for coil as well. So this becomes an incredibly busy area.
Yeah.
It actually doubles in terms of its use, because in the past with an integrated steelworks with blast furnace operations, we were using the deep water harbour.
Yeah.
Now everything is coming through here, coming in, and then it's going back out as coil. So it is really going to see some action.
So this is a direct connection with the mainline train lines, and I know you know you see trains of coils going through to Cardiff and Newport.
Yes.
But you say it's going to be twice as busy as it's been before, as you explained. Is there any work needed to go on here, or with the track itself, with the link with the works, or with the rolling stock?
The rolling stock, there's a lot of lease and alterations to all of the stock that we have here. So in terms of bringing in the scrap itself, it has to come in special containers to allow us to offload it very, very quickly to keep up with the throughput of the actual EAF.
Yeah.
So in terms of doing that, we have to buy wagons, we have to buy those containers, and really completely alter the way that we've been doing things in the past. So yes, there's going to be an awful lot of activity here. There's also going to have to be rail wagon maintenance here.
Yeah.
The whole thing is a different animal compared to what it's been in the past.
And 70,000 tonnes a week, that is a lot of material, isn't it?
Yes.
To be clear for people, that's not going to be unloaded here at the knuckle yard.
No.
That goes straight through to the site where it's unloaded at the scrap management
It'll
site.
get marshalled here for a short period, depending on what's happening on the main site.
Yeah.
And whether there are trains offloading already in there. So
Yeah.
you have to have a buffer between the operation of the main line,
Yeah.
because obviously there are windows where passenger trains and goods trains have got to run,
Yeah.
and the actual operation to continuously feed the electric arc furnace operations.
Yeah.
So this is our buffer area really to that.
Yeah.
And that's how the whole thing will operate in the
nice
future.
one. Well, it's definitely worth coming down here and having a look. It's an amazing place, and
Yeah.
you know, a place I've been before actually. And I guess the next stop on our journey will be kind of half a mile that way, and we'll see where those trains are going to land.
That's right.
And where the scrap's going to be managed. Let's go. So Peter, we've come onto site now, about half a mile from where we've just been in the knuckle yard, to a place that is known as Pea Fields, and it is a gigantic area. We can see in the distance the coke ovens, behind that will be the beach, behind where we are standing now I can see the steel plant a bit further off and the casters. You explained that the scrap, when it comes in by rail, lands somewhere, and this is where it lands. Tell us what happens here.
So this track is going to be a very important part of the infrastructure for the plant, and the material that comes on the trains from the knuckle yard will stop here. On those trains, the trains are about 400 meters long. Each wagon on those trains will have 2 containers on it. We call those rotainers.
Yeah.
And a rotainer is really like a very robust shipping container with no lid. In there we'll put the scrap, and that scrap will mainly come from England. There will obviously be collections in Wales and elsewhere, but mainly that scrap's coming from all over the UK, mainly England. And that scrap in that rotainer, then we can take that off the wagon, so that box comes off. We can tip that box upside down, and then we can take the scrap from there and then put the box back on the train.
Yeah.
And we're doing it like that because it is very fast in terms of the turnaround of the train, which allows you to get what we said, 70,000 tons of scrap here to feed the furnace. So that process will be continuous. We'll be doing that on every day, pretty much all day.
Yeah.
And this track and this general area will be the receipt area. Now, once we've got the scrap into this area, there are different types of scrap that we'll be taking for the furnace.
Yeah.
So not all scrap is created equal.
Okay.
Very much you've got things like demolition scrap, which is the big stuff that you might expect, beams, all sorts of bits and pieces in there from building, demolition. But you also have material like what we would call shred.
Right.
Shredded scrap is where you've got, let's say, clean stampings from car plants, that kind of thing. So it's perfect scrap for reuse in an electric arc furnace.
Yeah.
And we're going to use a lot of that. Now that type of scrap is almost flowable. So you can put it on a conveyor and it'll take it up into the plant.
Yeah, yeah.
And I'm sure we'll talk about that when we go further up. But the other scrap has to be moved in different ways. So all of that is kind of the mix that we've got here.
Yeah. And this area in front of us, you said 70,000 tonnes a week. And it's very difficult to imagine what 70,000 tonnes of scrap looks like. The area in front of us looks like, I don't know, maybe 10 football pitches. It's enormous.
Yeah, it is, yeah.
So how much scrap will be held here?
Yeah.
And what sort of considerations are we putting in place about the environment, the noise that could come from managing that scrap?
Well, the amount of scrap that will be held here will vary, but there will be a safety stock that we would carry for things like rail issues, that kind of thing.
Yeah.
Anything to do with weather events, that kind of stuff that's external to the site. So it's enough to keep the electric arc furnace running during those periods.
Yeah.
And also, they're to a certain extent, you want to buy scrap at the low price, not when scrap demand is high and the price is higher. So you can trade those things off. But there are limits within our planning as to how we can, planning approval, how much we can actually hold on site here.
Right, okay.
And in terms of how it can be stored, that's really important that, within the planning process, there are very stringent conditions on how this is laid out, how it's designed. Any runoff from this area is going to be dealt with before it goes anywhere near any other part of the environment. So we will be very, very stringent on that, and that design has already really been done. In terms of noise, which is the other thing that obviously people bring up, again, within the planning process, that's been dealt with. So that's a condition within the planning that we have to make sure is discharged.
Yeah, because actually we are quite a long way from, I hesitate to say civilization, but the town, even the motorway, you know, we've got the hot mill between us and the housing and the motorway and stuff, and it's just the beach that way. So I guess you've got some natural protection from the site itself.
You absolutely do, but there are points out there on the boundary of the town called receptors, and they're listed within the planning documentation, and we need to make sure that our noise levels are not above those that have been set previously from the site. So that has all been done and clearly demarked.
And as I said, it's a massive area. There's still quite a lot of work to be done here from the summer to get this place ready to receive scrap. What will this place look like in a year or so's time?
Well, this has got a couple of uses for us, believe it or not. So firstly, what happens is that when we get to the point where we're getting ready to mobilize the site, you'll end up with all of the amenities and the offices for the construction operations here, and all the car parking for the contractors and people who are working here. Yeah. It's a short walk to the plant from there, and it's important that we give the people who are working here for the construction project the best possible amenities and quality of working environment. So that's really important. This area here that you see, as we progress the project, we'll end up concreting an apron here that goes all the way down the line so that we can use the machines to take the containers off the wagons. So this area is got roadways, a road layout.
Wow.
There is some processing equipment that we require, which is to deal with material that's coming from our own existing operations, where scrap is yielded off the operations, and we've got to deal with that as well.
It's incredible, really, isn't it? Because I guess in my mind's eye, I was like, pea field, it's just a field, and you can tip a load of scrap there and move it over to the arc furnace. But the amount of work that's required is
huge. Yeah.
As I said at the beginning when we arrived here, Peter, over your shoulder there we can see the existing steel plant and the existing caster building. That's where the electric arc furnace is going to go. Now, that's quite a way away still, isn't it? I guess the scrap's still got to get from here to there.
Yeah.
Why don't we go to that end? We'll go to the boss plant outside, and then maybe you can talk us through how it's going to get there.
No problem.
Great, let's go there then, thanks. So Peter, on the way to the Boss Lagoon, we've taken a slight diversion, haven't we? And we stopped off because we started talking about the national grid connection and how that is going to be so important to the whole project. And we've come to a place which is between the coke oven gas holder that people might recognise with the Tata branding around the outside of it, they'll see it from the motorway, and the steel plant there. Talk to us a bit about that national grid connection, what work is involved, and what's going to happen in this area?
There's a huge amount of work going to happen here. The national grid power supplies run across on the other side there by the mountain, running along parallel to the coast. Between, really, you've got the steelworks and then you've got the beach. So the electricity connection we've got to take from that side of the railway line. National Grid are building a new substation alongside their existing one on the other side of the railway line. And that will take the power from their connection. We will then bring a cable which is about 2 kilometres long underneath the railway line. It'll come up through the fields on the far side there, be buried. And it will run then across here down to this area, which is where the other National Grid substation will be. And this substation will take power at 275,000 volts and transform that down to 33,000 volts, which is what we're going to use in the plant to power the electric arc furnace.
These are ridiculous figures, aren't they? The length of the cable, the power that is needed to be generated. And what will that look like physically, that substation here, is that something people would recognise that they've seen outside?
Yeah, it is broadly. Obviously, it's a very modern piece of infrastructure. There's 5 very large transformers going to be installed there, and the infrastructure that goes around that as well will take us, it'll take us most of the project to build it. So the start point for power into the site for us to commission the electric arc furnace is roughly going to be around October 2027.
Wow. Yeah.
So you can understand from that the size and length of and duration of the build. And this area, it's a couple of football pitches in terms of size for that whole infrastructure for the grid.
Yeah, and we're still quite away from the steel plant, if you don't mind me saying.
We are.
And I kind of think, well, why do they not build it a bit nearer?
It's about what you want to prioritise, and for us, the important thing is actually the distance that the scrap has got to travel. So we want the shortest distance for the scrap to get to that plant. Yeah, and it's also about just geographical location within this site, because we've got an awful lot of other stuff going on. We need to make sure that all of those different competing aspects are catered for and prioritised.
So this can almost be a ring fence project on its own, because as you say, it doesn't really, apart from the fact it's got to come across a bit of the site, it doesn't really interfere with your main arc furnace and scrap preparation, does it?
No, it doesn't, and that's what we've tried to do for our colleagues and the partners that we're working with National Grid. It's important that we give them a safe area that they can work on independently of us, that we don't interfere with them and they don't interfere with us, and we have issues in terms of the sequencing of the work. Yeah.
So we've talked a lot about the preparation, how the scrap's going to come in, where it's going to go. We've talked about the National Grid connection. I'm dying to get over to the steel plant and talk about the electric arc furnace and how the scrap goes in there. So why don't we go over there now?
Great.
Nice one. So Peter, we haven't come very far actually, have we? We're stood on the edge of the Boss Lagoon, which is like a giant lake. It's a beautiful lake with cormorants standing on the railings and so forth. This is the cooling water for the Boss plant, or as was. Explain to me, the scrap from pea fields that we talked about earlier has got to get to the steel plant, and it's going to go across part of this lagoon, is that roughly right?
Broadly speaking, yes. So the pea field is about 250 metres over there where the scrap will be coming from the rail line. And we're going to bring the scrap in on tipper trucks from there, and it'll come across here. We need to fill in part of this lagoon, which is a strip around the side there, to get it to where the scrap handling will be for the plant, which is called the Consteel system. And that will be over there in that area. This whole area will be infilled, so the strip will be infilled into the lagoon. Yeah. Keep most of the lagoon, actually, most of it will be retained. But that allows us then to use the rest of this area for a lot of the utility plants that we need, water cooling, electrical distribution, that kind of thing for the arc furnace. Yeah. So we need more space on this side of the plant. The reason why we've built the plant in this configuration is because at the end of the day, the scrap is coming from the rail yard that we were just in. Yeah. And what we need to do is make sure that we are able to get the scrap as quickly as possible and in as short a distance as possible to the furnace.
Yeah, and I've seen the engineering drawings, and these 2 car parks in front of us for the casters, they're all going to have buildings and units on them, as you were describing. The building in front of us, which is the existing steel plant and casters, is where the electric arc furnace is going. Right. There's a big shed on the left with a blue roof, which is currently where scrap was the scrap bay.
That was the old Boss plant scrap bay. So on an integrated steelworks, the blast furnace operations, you would end up putting 18% scrap into the iron to make the steel. So that whole building was doing that. Now, obviously, what we're going to do is put a huge percentage of scrap in. So that's 70,000 tonnes a week has got to be fed into the arc furnace in that area. So actually what we're going to do is we're going to knock down that building, and that whole line along the side of the lagoon is being flattened so that we can put a huge Consteel conveyor system in, and that actually will continually feed scrap to the furnace. and that really raises the throughput of the plant massively.
Yeah.
So that's why we've chosen that design of plant to actually achieve that throughput.
Yeah, because I've spoken on the podcast before. My early career started in British Steel Stainless with an electric arc furnace. It was bucket fed.
That's right.
Electric arc furnace, and this is a conveyor. And as you said, again, I've seen the drawings, I've seen the plans. People might be listening to podcasts and watching the video, say, "Oh, they're going to have a conveyor and they're going to put some scrap on it." This thing is massive, isn't it?
It is, yeah.
That whole
Yeah.
construction, which goes alongside the lagoon as you described there, feeding into where the electric arc furnace is going. Can you give us an idea of the scale of that?
Well, it'll be about 300 meters long for that literally that conveyor. The actual building is, I think it's about 20 meters wide.
Yeah.
And we can store scrap inside that building, but also we have other conveyors that bring the scrap into that system.
Yeah.
So that building also will have a couple of big cranes in there with magnets on to lift
Right.
scrap.
Yeah, yeah.
So there's numerous different technologies that are used there to get the scrap to the furnace,
Yeah.
and also to make sure that we understand how much scrap is getting to the furnace. So we'll weigh the scrap as it moves down the system to make sure that we're continuously feeding the process.
Yeah.
The plant will be able to do about 400 tons per hour of scrap to give an idea
Yeah, yeah.
in terms of
And it's an
size.
incredible thing, isn't it? And I think I'm right in saying you may have mentioned about that scrap gets heated before it goes into
Yes.
the electric arc furnace. That's integral. I guess that's kind of just outside that building there, is it? Or is it within
It's-
the building right next to the furnace?
It's actually coming out into that new building, so that scrap will be preheated before it goes in. That saves us a little bit of energy
Yeah.
in the process, which is obviously a good thing.
Yeah.
Electricity as a result. In terms of the rest of that bank, will also be taken away to put a new fume treatment plant.
Yeah.
That goes on that bank as well. At the moment, the team over there are removing about 5,000 tons per day from that bank as part of a drainage scheme that we're doing
Yeah.
on this area.
Yeah, this whole landscape is going to change radically, and I know you
Huge.
said the lagoon is going to stay, and I'm delighted because it's a beautiful place to stand actually and look across it, and it'll be fascinating to see that.
Yeah.
I guess the next part of our journey, Peter, is to go over to the steel plant and go inside where the electric arc furnace is going to be built. Because that whole bay that you can't really see from this perspective, but that whole bay going back to where the hot iron used to come into the steel
right.
plant, all that bay is changing.
It's all
it'd
going to be used, yes.
It'd be fascinating to hear from you what's going in there alongside the electric arc furnace. So,
Great.
can we go in there now?
Of course.
Perfect.
Let's go.
So Peter, we're now stood in the bay where the electric arc furnace is going to be built. Just on our left is that blue shed we described before, which is the scrap bay that used to operate. And behind us we can see, well, I can see all sorts of stuff. There's the old scrap car there. There's some hooks for the ladles. There's a ladle in the background. And I guess where that ladle is pretty much where the arc furnace is going to be.
That's exactly right.
It's going to be a biggie. And but you were saying it's not going to be floor level. Talk to me a bit about that.
So the ladle has to fit underneath the furnace because
Yeah.
you've got to be able to tap the furnace. So the furnace is actually going to sit above the level of that ladle, if that gives an idea of size.
Yeah.
The furnace is it's a 320 ton tap weight furnace. When the furnace is running, it will have another 160 tons called a hot heel, which is like a sump of hot metal that sits in there at all times, unless we're obviously inspecting the refractories inside the furnace.
Yeah.
So it retains 480 tons at the point it's going to tap when we tap the furnace.
Wow.
So that shell of the furnace, the furnace diameter is about 9.3 meters, to give an idea of size, and that really will fit across the bay here.
Yeah. So
And the furnace will tilt one way and the other, one to tap and one to slag the furnace off to remove all the impurities from the melt.
Yeah.
And then above that then will be the floor. So we have the floor where we'll operate the furnace. And again, on further above that again, you'll have the mast. So the furnace has a mast which holds the electrodes.
Of course, yes.
And those electrodes move up and down into the shell of the furnace to create the arc.
And so the frame of this building stays. I mean, we're looking down there. It must be between where we are on the end of the building must be best part of 100 meters, and the building looks like it's 20, 30, 40 meters high.
It is.
That's all going to be full.
It
but
is.
the frame's staying.
That's right. So the construction of the bay, this plant was built in 1968. Building's a very, very robust building, and obviously we're checking it, and it has had lots of checks done to make sure that it's suitable for further duty.
Yeah.
But we're also going to extend the building out that way as part of the development to provide more space on that side. So this area has got a huge amount of work going on in it at the moment, as you can see. So as you said, here are the old hooks that used to pick up the 500-ton ladles in the bay. And all of this is going to be cleared now, ready for construction to start in July.
And where we're standing, Peter, am I right in thinking that the ladle, once full of 320 tonnes of liquid steel, comes up towards us?
It does.
And then what happens to it?
So underneath the furnace, the ladle will sit on a car, and that when that ladle is full of 300 tonnes of metal, the car will come out from underneath the furnace. We'll pick it up then with one of the large cranes here, with 500-ton cranes. And then we will transport that down the bay to this area over here, and then bring it through into what we call the teaming bay. And in the teaming bay, that's where we do all our secondary metallurgy. That sets the grade of the steel, it sets the temperature, and then we can progress that into casting.
Yeah, and I'd like to walk through there in a minute, because I didn't mention it earlier, but part of this investment is not just the electric arc furnaces, two ladle metallurgy furnaces, which is the secondary steel making, which is across in the next bay, and in addition to some of the assets that we currently have in there. So let's take a walk across there. Before we go, I'd like to go up onto the stage, the existing Boss stage, because I want to talk to you a bit about this concept of having a spare shell for the electric arc furnace, because I think a lot of people will struggle to understand that. But it'd be interesting to see where it's going to go and how that's going to work.
No problem.
So I guess if we go that way,
that's
right. The stage.
Let's go.
Yeah, perfect. Thanks. So Peter, a little bit out of breath, so we've climbed up from the bay where the electric arc furnace is going to the stage. So this is where the two Boss converters have been operating for as long as we've known them. Obviously now ceased operation. But this other end of the bay, so this is the north end of the bay, where traditionally hot metal came from the blast furnaces and the torpedoes was put into a ladle, desulfurized before it went into the converters. This end of the bay is not redundant, is it? There's some stuff happening here as well. Tell me what goes on here.
Believe it or not, we need the entire length of the building, and it's a huge building. It's a cathedral, isn't it?
It really is.
And we've got in the south end of the building, we've got, as you said, the electric arc furnace. You're going to be moving hot metal ladles when the plant's running. But then the rest of this bay is required for other aspects of maintenance of the plant. One of the biggest ones is that we have to, on a very regular basis, change out the shell of the furnace. So as I said, that shell at different times can contain 480 tons worth of metal. And the refractories inside that shell are very thick, but they do wear from that kind of intensity. So what we have to do is every couple of weeks, when the plant's in full production, we have to change that shell out complete.
Wow.
And then we put another one back in. So the crane that we'll be using will be rated for that, but it's something like a 580 ton potential lift. And that will do that every 2 weeks and change the shell, put a new one back in with new bricks in, so that the thing is safe and we carry on running. So it can be done very quickly because it's designed for that. So it allows us to change a shell, when we get slick in less than 8 hours. That's the kind of the way that this will be done.
And it's interesting because you talk about it as a shell, and people might think, oh, like a shell of a crab. But I think when most people think of an electric arc furnace, they're probably thinking of that shell. It is kind of the whole furnace without all of the...
Literally the whole furnace comes out. So you're left with the frame that it sits in, that tilts it. As I said, it has to move backwards and forwards. But the actual shell of the furnace, the bit that actually retains the metal, injects the oxygen, delivers lime, all that will be coming out and being replaced once a fortnight.
So we're having two effectively, aren't we?
We are, yeah.
So that's what this end of the bay is going to come for. For the refractories, for the ladles is also going to be at this end somewhere?
Yes, all of the refractory maintenance will be at this end of the building. and it makes it quite a neat setup. We can keep the personnel who do that together.
Yeah.
We have the flexibility that confers,
Yeah.
and also it keeps the environment in the right state for doing that activity.
Yeah, it's going to be a busy old place, isn't it?
Yes.
And I know, you know, people feel sad about the end of traditional steelmaking in this bay, and it was busy from both ends. But in the future, it'll also be busy from both ends. But I'm guessing there won't be that many people about because it'll all be controlled from a pulpit somewhere, will it?
Yeah, the pulpit will be down there, and it'll be a combined control area with the ladle furnaces that we're about to go and have a look at.
Yeah.
But where they're going to go. And yeah, there are less people. Unfortunately, that's the way things move and technology moves. And we see that in many industries. But there'll be a lot of interesting jobs for people here from engineering, production, technical, any kind of maintenance and projects background. There'll be lots and lots of things to do here.
Yeah, and I think people will be very pleased to know that this bay will be fully utilised with the new process, even if it's in a different way to how it was done before. So, listen, good to come up here and have a look and understand the scale of it and talk about that second shell. I think secondary steelmaking will be that way, if my memory serves me correct.
Right.
Let's go and talk about the ladle metallurgy furnaces and what's staying there, and the importance of those new ladle metallurgy furnaces in being able to make all the grades of steel that we want to go forward.
Let's go.
Perfect. Okay, so Peter, we are in now secondary steel making, the teaming bay, I think you call this.
That's right.
And, you know, as far as the eye can see, both sides really is equipment, ladles, the teaming bay ladles, and some existing secondary steel making. Talk to us a bit as we walk along about what we've got here, what will be staying, and the new 2 ladle metallurgy furnaces. So
on our right-hand side is where the steel will be coming from. So it'll be coming in, the ladles from the EAF will come through into this bay on a car.
Yeah.
They'll then be picked up by another 500-ton crane and moved down to the ladle furnaces.
Yeah.
And we've got 2 ladle furnaces that we're going to install. And the reason why we've got 2 and not 1 more furnace is because it provides us with a lot of flexibility in the operation, and it allows us to use the 2 existing casters here to actually process more steel.
Yeah.
So it increases our opportunity to make volume through this plant, and it's really quite important. So running an EAF, ladle furnaces are very important in the whole process cycle. It allows you to set the temperature really, really precisely to then go to the casters, which is again is part of our process, but it means that you don't waste energy or waste money in terms of setting that. Yeah. But also, we'll still make many grades through this plant, steel grades, and that means setting chemistry. So you might be adding manganese, chrome, all sorts of things will be added as alloys to the steel that we produce on the electric arc furnace, dependent on the end customer. So those end customers have different metallurgical requirements, and we have to cater for that. So it's a key part of the argument about the business being able to supply the customers and the markets it currently does. It's saying we're investing in these ladle metallurgy furnaces that will enable us to refine the steel, for want of a better word, to those grades. Now, before we just go on in a bit more detail, I know we're talking to some people around the business and outside the business, and they hear the word furnace, ladle metallurgy furnace. They think of something that's going to be the size of a blast furnace or the size of an arc furnace, but these things are the size of a ladle. Would that be fair? That's right. Yeah, they're akin to, in terms of the fact that to an EAF in terms of them having electrodes, but it's a much lower power activity. So what you're doing is you're using those electrodes, as I said, to set a temperature. You're adding those alloys. You've got to do a thing called stirring, which is where we mix the alloys in with a gas from the bottom of the ladle. So they've got a number of functions that we've got to do, which take a bit of time in our process. You absolutely couldn't just build an EAF and leave it like that. You have to build those ladle furnaces to make the whole thing sing.
And of course we are keeping some of our existing secondary steel making. As
are.
we walk down the bay, just to our left, there's like a giant tunnel, for want of a better word, which takes you through to the casters. But this also has a piece of secondary steel making, which we're keeping. Why are we not just converting from one to another?
When this plant was running as a basic oxygen steel making plant with the blast furnaces supplying the iron to make the steel, this bay had 4 secondary steel making units in it. And effectively what we're doing is we're building 2 new ones which suit the EAF process, which are the 2 ladle metallurgy furnaces. I'm going to keep 2 of the existing units which have been here for many years, which is CAS2, which is what is in front of us here, and another plant called the RD degasser. And they again provide us with flexibility in the operation to the casters in terms of making sure that we can supply at the speed and rate that we want in terms of production, but also the RD degasser gives us a wider product range. And that's really important. We obviously want to make sure that we can be as flexible as possible as things progress and, you know, requirements change over the years.
Yeah, sure. Now, it's really so fascinating to hear about everything that's within your remit, really, as a program manager, because it's unbelievably massive. And we stand in this cathedral of a building, but it's 3 almost next to each other. You've got the main steel bay, you've got the teaming bay, and you've got the casters, which is also part of your responsibility. The life extension project to the casters that we've spoken to Rob Deeney about before. It's quite difficult to get your head around the scale of this project, Peter, if I'm honest with you. Got a lot of work ahead of you.
Absolutely.
How are you feeling?
But we've got a great team.
Yeah.
This is not done with one person. It's not done without a load of great people, many of which have come from this actual operation here.
Yes.
Or they've come from the blast furnaces. We've got a team of, I have to say, really can-do people. What we've got to help them with is the project management, project engineering, which is something that perhaps we, they've been doing operational roles with us. We now need to make them into great project engineers, project managers. I have absolutely no doubt whatsoever that they will be fantastic. It's just not even something to consider that they won't be able to do it. So I think that we've got a great team. They're already getting stuck in terms of how to plan the work, how to execute the work, and many of our processes that we need for project engineering and management of a big project are in place now, and we've been doing that for maybe the last 18 months in reality. Not just that, we're placed a lot of orders now, Tim. So
that's right.
Again, this week we've placed another £15 million worth of orders yesterday. Thing is moving on very, very quickly, and actually bring it on. I think that's what people want.
And that's what we're delighted to hear. And, power to your elbow, the whole of you and your team and your contract partners, because it is an enormous undertaking. It is all about the future of the steel industry in the UK, certainly from a flat products perspective. And it's all about that journey to a green steel future that is so demanded by society, it's so demanded by our customers, and is the right thing to do for any business. And we're firmly on that journey. And I wish you all the very best to you and your team. I'm very grateful for you to take so much of your time out today showing us around, Peter. I know there's more we could talk about, but I think now we've kind of set the scene. My ambition would be to come back with members of your team and dive into the specific projects within it. And that's our plan over the next 3 years. For those of you listening to the podcast and watching a video on YouTube, I do urge you to subscribe to both and follow us on our green steel journey, because our ambition is to tell this story over the next 3 years between now and the time that the electric arc furnace is up and running alongside all the other infrastructure that goes with it. And it's not stuff you're going to see on the telly, if I'm honest. We get special insight with people like Peter, people like Andrew McGregor, who we're going to talk to next, who's working on the hot mill development, the new picker line development, which is also part of this investment programme, to go into those details so you can really find out from the inside what's happening here in Port Talbot and the effect of that on UK manufacturing and our customers and our Tata Steel colleagues through the supply chain. So once again, Peter, thanks very much for joining us, taking time out. It's been an absolute pleasure. I've been waiting 3 years to do this podcast. I'm delighted we finally managed to get here, and we'll definitely be back to talk to you again in the near future.
Anytime.
Super.
Great stuff.
Thanks very much, Peter.